I'm back again with another set of videos. In this video, what I'm going to do is I'm going to discuss coupling with you. This is another design principle which helps us to, let's say, manage our sub-module or module in a quick manner. Reason is, if coupling is less, certainly your design will be more reusable, more easy to manage, right? So whenever you want to divide your module into some module or your system into modules, you should make sure that the coupling is least over there. There are different types of coupling which I'm going to discuss in this video. Certainly you can use these videos maybe if you want to be software designer. This knowledge is going to help you a lot. Okay, so let's start with the video. So I'm going to show you now. So next design principle is coupling. In coupling, what is our major requirement is wherever coupling is found in software design, it is expected to be minimum. So coupling occurs whenever there are interdependency between one module and another. In general, what I can say is that the more tightly coupled a set of module is, hardly it is let's say it is very tough to understand those modules. Now there are two major reasons for this, right? So whenever there is interdependency between modules, if you want to change at one place, you have to make those changes somewhere else as well. Now requiring changes to be made in more than one places is quite problematic, since it is time consuming and it is tough to find different places that need to be changed, and certainly it is likely to create error. Second thing is that whenever a network of independency exists, it is difficult to identify how a particular component is going to work. So coupling also implies that if you want to reuse one module, you will also have to import those with which it is coupled. For example, one module is using another one. So to use X1, you need to import Y1 as well. Correct. This is because coupled components need each other in order to work properly. This is the main reason. Now to reduce coupling, you have to reduce the number of connection between modules and the strength of the connection within module. In this diagram, if I show you, can you see that this particular module, this particular figure in which there are lots of interconnection, right? While in this interconnection is less. So this is known as less coupled module. This is higher coupled module. Right now there are various kind of coupling: content coupling, common coupling, control coupling, stem, data, routine call, type use, inclusion or import or external. See, all these kind of coupling are very important, but the thing is you have to remember this order. For example, if in your program content coupling is there, that is more dangerous than common coupling. That is more dangerous than control coupling. So you have to remember this order. Try to remove the coupling which has content before common one. Got it? So I am going to explain it one by one now. Now the next kind of coupling is known as content coupling. Now this kind of coupling occurs when one component surreptitiously modifies data that is internal to another component. This surreptitiously means secretly. For example, one particular data is declared in one particular part. Now other part secretly modify that particular data. Then this kind of coupling is known as content coupling, and this is one of the most dangerous coupling. Now for example, you are declaring some variable in your module, right? Let's say you are declaring one employee class. Now in that employee class, let's say you have email ID, phone number. Let's say this data is actually being accessed in other part of the classes, let's say, or other part of that module, let's say person class. Now this is not allowed, right? So if you allow this kind of transfer, now certainly your data is going to be corrupted. So what you are going to do is you are going to design, let's say, to reduce content coupling, you should therefore encapsulate all instances. Encapsulation means, for example, I'll come to this in a while, but before that I would like to tell one more thing, that this kind of coupling you should always avoid, since any modification of data should be easy to find and it is understand. But in case your two modules are, let's say, coupled together na, certainly you are not going to understand them. Right now, there is a programming language called Java, right, that handles this, right, that how it handle that kind of let's say coupling. They don't have any kind of manipulation of pointers. Since pointers are not there, so content coupling is not there. This is one example. The one example which is mentioned on this slide is like, for example, you are declaring one particular instance as public. Public means accessible everywhere, right? This particular content coupling suggests that declare your variable as private and provide a get and set method to access those. Correct. So this is how you're going to do it. But still, this kind of coupling can still occur. A worse form is content coupling occur when you are directly modifying an instance variable of an instance variable. For example, you are declaring an object of employee class or an instance of employee class, let's say E. In that E instance, you have further instance variable, for example, E dot number, E dot name. If you use this directly, this is still accessible, right, through some method or something. So this is also example of content coupling, right? Now, for example, in this case, this is very good example over here. Can you see that there is a class line? In this, there are 2 points, start and end, and there is one method get start and get end. See, the variables are private, right, but the method are public. Now arc class is secretly creating an object for base client. Now this is not directly accessible, right, but what it's going to do is it is going to access that particular value through get end method, right? This is still coupling is over there, right? See, now getEnd method is there. Now it is going to modify the value of getX. New I value will be provided by R class. So this is one kind of coupling. Now if you make changes in this class, you have to make changes over there, or the changes done by over here is going to be deflect over here. Correct. So this is how coupling works. So this is not good for our programs, right? But you have to deal with it, because if you let's say two modules cannot communicate with each other, there is of no use, right? So let's move on to next coupling. This is known as common coupling, right? Now this kind of coupling occurs whenever you use global variables. See, all the modules using global variable become coupled to each other and to the module that declares the variable, right? Now the coupling occurs because changes to the variable declaration will affect all the code that uses the variable, right? One more thing, let's say changes to the way one module uses a variable will have an effect on all other modules that is going to interpret those variables. Now, a weaker form of common coupling is when a variable can be accessed by a subset of the system's classes. For example, in Java packages. Now, it can be acceptable for creating global variables. See, this common name is like one particular common variable that is being shared by all, right? For example, in your let's say Java lang.math package, there is a constant called pi, right? Now, as in the case of content coupling, common coupling can also be done, let's say reduced by encapsulation. Now pi, that constant is accessible everywhere, right? Now similarly there can be another variables that can be accessed many places. Now if someone changed the value of that variable, certainly it is going to impact that, right? Now for every global variable you should create a module that is specially designed for public methods. For example, that can be created to call get or set method, or let's say you want to represent some you have some internal representation of the data that can be more easily changed, and the set method that can verify that changes are valid or not, whether to accept those changes or not. So encapsulation is the only solution to remedy common coupling, right? Next, control coupling. Now in control coupling, sorry, this kind of coupling can occur
when one procedure call another by using some sort of flag or command that explicitly control the second procedure. For example, let me take the example first. Then in this particular method routine X, right, this method will be called by some method. The method will provide some argument of string type that is known as command, right? Now if command dot equal draw circle method will be called, else draw rectangle will be called. Now this routine X method will have to change whenever any of its caller adds a new command. For example, it's like draw, no, let's say rhombus. It has to be changed. It should be probably changed if any of its caller deletes a command, obviously. Otherwise, it will have a code that is set to be dead. For example, let's say draw circle is being, let's say, deleted. Now this command, if you don't delete it, it will be dead code, never execution code, right? So now control coupling can often be reduced by simply having the caller of the routine directly call the method. For example, if one particular caller, it directly calls draw circle, draw rectangle. No need for this. But what we usually recommend, we recommend to use polymorphic operation. For example, in this case, right, it can be done like this. Two separate classes you can create, circle and rectangle. Now routine could then just call draw method with that system choosing the appropriate method to run on runtime, correct, or execution time. So there are some cases when control coupling cannot or maybe should not be completely avoided. For example, if you are using some simple chat server, right, simple chat server you are using, right, in that case, let's say there is some method over there that handles message coming from client, right? Now this method is let's say tightly coupled to simple chat client to generate command, so you cannot avoid this, right? One way to reduce control coupling in this case would be like you can create a lookup table, right? Lookup table means let's say you have created one table that is mapped to one command, to a method that should be called when the command is due. But still it also created some sort of coupling, because whenever particular modification you require, you always need to change the lookup table, right? So this is also another kind of coupling, right? Next is stamp coupling, right? In stamp coupling, now this kind of coupling occurs whenever one of your application class type object is as a method argument. For example, you are creating an employee class, and the employee class you have created an object of that, and that is acting as a let's say argument for your method, correct? So now I have example for this here, yeah. For example, there is a class called emailer. In this there is a method called send email, and in this you have employee e as an argument. Now imagine this employee class, it has many instance variable, like it has a name, it has address, it has email, it has salary, it has manager, and many methods to manipulate this variable. Now any method that is passed an instance of employee, just like here, right, any method will have full access to all the variables. Yes or no? Yeah. So it will have full access to all the variables, right? Now this method send email in in this class emailer will have access to will actually wants to access only email and name maybe, right? So now but it will have access to all the variables, so it can disturb the functioning of the class. It can create some sort of side effect, correct? Since it has been already given access, so there will be like let's say while maintaining the program, right, or any maintenance changes in name or something will have certainly bad impact on this. So your emailer class cannot be used, or let's say reuse, because it is certainly going to impact it, right? So now in stamp coupling there are two ways which through which you can say reduce stamp coupling. First way is you can create an interface, and second one is you can pass simple variables. Now if you replace the class variable as an interface, what changes it is going to occur, right? Do remember, if you are using as an class variable, it will be called as object, and if you are if you are using it along with interface, it will be called as reference variable. Got it? So now let's say, instead of using object employee, I am going to use an reference for interface, that is known as address. Now address is there. Now in case I replace employee class object with interface reference, the stem coupling is reduced. Reason is, since send email method now have access only to the name and email data that is truly it needs, right? And now if I change to the employee class, certainly it is going to have less impact, right? Second thing, the send email method will be impacted if address interface is changed, although chances of doing this is let's say very rare. Now one more thing, this address interface is now easy to use. Certainly my employee class is now reusable, right? Now there is another case, like you can create, instead of creating address interface, you maybe consider it, let's say create a superclass called person for employee. Now you can create send mail method in that, but still I believe that instead of creating class and class, one interface is a better option. It is more flexible, right? Now there is another solution which is mentioned over here, that passing simple variables. Now second solution is like this. So instead of providing the class object, you pass on name, email over here, and string text instead of this. Now this had another kind of coupling, right? Now I'm going to explain this kind of coupling in next slides. So let's move on to data coupling. Now this occurs whenever the type of method argument are either primitive or simple classes such as string or something. Now what you need to do is, you need to reduce coupling by not giving methods unnecessary argument. If you give unnecessary argument, certainly there will be more coupling and you will not be able to reuse your code. Now the more the number of argument a method has, higher will be the coupling. This is because each caller to the method must have a code to prepare the data for each argument. Now if you want to change in how the method declares or interprets each argument, may require, now you have to change each caller's code, right? So wherever you are calling from, you have to change that code. Now see, there is a trade-off between data coupling and stem coupling. In this case of a single argument, data coupling is considered as a loser. Let's say you are using this one, you're using this single variable, data coupling is certainly lesser. If you are using this one, data coupling is more, right? So it can be easily understandable that if you use more variable, data coupling is going to be more. If you are using less variable, it is going to be, let's say, more, right? Now thing is, if you replace a single complex argument with many simple argument, certainly the total coupling will be more. So it is suggested that you always use single complex object instead of using multiple single object. So this is what data coupling states, right? So next coupling is routine call coupling. Now this is also but obviously its priority is lower than the previously defined coupling, right? But it is important. This kind of coupling occurs when one particular routine or one particular method calls another one, right? Now the routines are coupled because they depend upon each other's behavior, and caller depends on interface of the called routine, right? Now the routines are coupled because they depend upon each other, right? This let's say this sequence is repeated again and again, right? So now it may create some sort of side effect. Reason is, let's say if you use a sequence of 2 or more methods to compute something, right, and this sequence is used more than one place, then you can reduce routine coupling by writing a single routine that encapsulates the sequence. Now, thing is, if you are repeating the same process again and again, if you change it one place, you have to change it other place. So that's why it is recommended, if you have more than one call for a, let's say, specific routines, better to replace with single routine and put it somewhere else. This is what routine call coupling is. You should reduce it. Type use coupling. Now this may let's say this may look similar to like the previous defined coupling, right, data coupling, but it is different, right? This kind of coupling occurs when a module use a data type defined in another module. The type use coupling naturally occurs in type language. For example, Java is there, right? It occurs anytime a class declares an instance variable or a local variable as having another class. For example, you are using employee class variable into person class. That is known as type use coupling. Now this is similar to common coupling, but instead of using data being shared, only data type is shared, right? Now the impact of obviously sharing data type is less than sharing data, right? So this kind of coupling is considered as less problematic than common coupling. Now the technique for reducing stem coupling can also be applied to remove type use coupling. For example, you should declare the type of variable to be the most general one, right? So or you can use the interface for that. For example, while creating a variable that is to contain a collection, you should normally declare it to be a type of list. That is, any class that is going to implement that interface, that is java.util.list, certainly maybe it's array list, linked list, or vector, certainly it can store that, right, if the variable is of type list. So this is how you can reduce this kind of coupling. Next is inclusion or import coupling. Now import coupling occurs when one component import a package, for example in Java, or inclusion coupling when one component include another file, for example in C++. Doing this means that including or importing component is now exposed to everything in the included or imported component. Now you are importing some file, let's say java.math or lang or something, right? So now that file is totally exposed in this, right? If you allow changes to that particular component, certainly it is going to impact, right? So now an item in important component might have same name as something you have already defined, so it creates problem. Last coupling is external coupling. This is very easy to understand. This coupling occurs when a module has a dependency on such thing such as operating system, shared library, or hardware. Now the best way to remove this is you have to reduce the number of places in your code wherever such dependency exists, right? There is some example mentioned, the facet design pattern can reduce external coupling. That's a different kind of topic. I'm not going to dive into the detail, but you can remember there are some design pattern which helps you to, let's say, find the solution in a more better way, right? So if you use this kind of design pattern, you can reduce external coupling, right? So that's all for this video. If you have any question, comments, suggestion, you can comment below, right? I will try my best to answer it. Thank you so much.